Today we will be looking at Chapter 1, where we're talking about sampling and data. As we get started, you're probably wondering, why statistics? Why do we need to take this course? To answer that, is anybody here interested in sports, criminal justice, education, politics, real estate, psychology, science, business, computer science, mathematics, or the medical field? Now I'm guessing that I've hit something that piques your interest in some way. Every one of these areas that I've listed here touches on statistics. Every one of these areas will use statistics in some way or another. So even if you don't think you'll use it in your future career, if you're interested in one of these areas, most likely you will use statistics at some point in your life. So now, what are we going to cover in this chapter? In this chapter, we will learn key terms that are fundamental to probability and statistics. We will learn various sampling techniques. We will learn to design experiments. And this chapter gives us the foundation for conducting experiments and studies of our own. So let's get started with some key terms. Data. Data is defined to be a set of observations. Probability. Probability is a number between 0 and 1, inclusive, that gives the likelihood of a specific event occurring. Keep in mind that probability can equal 0, it can equal 1, and it can equal anything between 0 and 1. But probability cannot be negative, and probability cannot be more than 1. The next key term is population. Population is all individuals, objects, or measurements whose properties are being studied. Next, we have parameter. Parameter is a number that is used to represent a population characteristic, and it generally cannot be easily determined. One of our tasks throughout this semester will be to estimate parameters based off of samples that we take. Next, we see sample. Sample is defined to be a subset of the population studied. Statistic. A statistic is a numerical characteristic of a sample. Now, on our last slide, we defined population and parameter. So a sample is a subset of this population. So the population being all objects that we're measuring. So it's all objects that are being studied is the population. So the sample is just a subset of that. Now, statistic is going to be a numerical characteristic of our sample. We can use these to estimate the parameters, which are numerical characteristics of the population. Next, we want to talk about a representative sample. A representative sample is a subset of the population that has the same characteristics as the population. When you're doing a study, it's important to make sure that you do have a representative sample. For example, if you're wanting to study the vertical jump of Peru State College students, it may not be good to just study the basketball players, because basketball players are more likely to have a higher vertical jump. So if you only studied basketball players, you would probably not have a representative sample. So remember, a representative sample is a subset of the population that has the same characteristics as the population. So let's talk about data. We could have qualitative data, which is data whose value is indicated by a label. We could also have quantitative data. Quantitative data is data whose value is indicated by a number. So think qualitative, talking about qualities, quantitative, talking about quantities. We also have discrete. Discrete is a type of quantitative data. Discrete is quantitative data that is the result of counting. So these have to be whole numbers. Continuous is also quantitative data, but this is data that's the result of measuring. So this can include fractions or decimals. We also want to talk about levels of measurement. Nominal is one of our first levels of measurement. So nominal data is data that cannot be ordered, nor can it be used in calculations. So you're thinking it's most likely going to be qualitative, and there's no specific order to it. Ordinal data is data that can be ordered, but the differences cannot be measured. Typically, you're thinking here still qualitative data, but now it's something that can be ordered. An example of nominal could be color of football uniform, its categories, and there's no order to it. You can't say one is better than another. An example of ordinal data could be your class standing. There's freshman, sophomore, junior, and senior. And there's an order to it, right? Freshmen, then sophomores, then juniors, and then seniors are at the top. So nominal and ordinal, we typically think of these as being qualitative data. Next, there's interval. Interval data is data with a definite ordering, but no starting point. The differences can be measured, but there is no such thing as a ratio. Finally, we have ratio data. Ratio is data with a starting point that can be ordered. The differences have meaning, and ratios can be calculated. So thinking about the difference between interval and ratio, you want to ask yourself, is there such a thing as zero meaning nothing for this data? Some nice examples of interval would be any type of temperature measurement or standardized testing score. Ratio would take care of and cover most of your other data values that you talk about that are numerical. Both interval and ratio are going to be your quantitative data types. Let's spend a moment talking about sampling now. There's a few different ways that we can collect samples. The best way would be to use a simple random sample. This is a straightforward method for selecting a random sample. Give each member of the population a number. Use a random number generator to select a set of labels, and these randomly selected labels identify the members of your sample. This is the best way to conduct sampling. Now, it's not always practical, so sometimes other methods are needed. The next method we will talk about is the stratified sample. Stratified sampling is a method for selecting a sample that's used to ensure that subgroups of the population are represented adequately. You divide the population into groups. Then you use simple random sampling to identify the number of individuals from each group. Next, there's cluster sampling. Cluster sampling is a method for selecting a sample and dividing the population into groups. You're going to use simple random sampling to select a set of groups. Every individual in the chosen groups are included in the sample. Now, stratified and cluster look fairly similar. So what's the differences? With a stratified sample, you're going to get a few people from every single subgroup. With cluster sampling, you're going to get everyone in just a couple of the subgroups. Next, we have systematic sampling. So a systematic sampling is a method for selecting a sample. List the members of the population. Use simple random sampling to select a starting point in the population, then choose every kth individual in the list starting with the one that was randomly selected. If necessary, return to the beginning of the population list to complete your sample. Next, we have a convenience sample. Convenience sampling is a method for selecting a sample. This method selects individuals that are readily accessible and may result in biased data. At the end of the semester, you will be completing a project where you are actually going to conduct a research experiment. During this, you will have to collect a sample. When you collect a sample, I want you to make sure that you avoid using the convenience sampling method. A couple other notes that we should make about sampling. You could do sampling with replacement or without replacement. So sampling with replacement is once a member of the population is selected for inclusion in the sample, that member is returned to the population for selection of the next individual. Meaning you can have the same individual being sampled more than once. Now, sampling without replacement is different. So with sampling without replacement, a member of the population may be chosen for inclusion in the sample only once. If chosen, a member is not returned to the population for selection before the next selection. So think about it as if you have a deck of cards and you're just keeping track of what card you've drawn. So sampling with replacement, you would draw a card out, make note of what card was drawn, and then you'd put it back into the deck. For sampling without replacement, you would draw a card out, make note of what it was, and set it off to the side before drawing your next card. Let's talk about experimental design. You could perform an observational study. An observational study is where the researcher merely observes and does not control how subjects are assigned to groups or which treatment each group receives. There's also experimental studies. So in an experimental study, the researcher assigns subjects to groups and has control over which treatment each group receives. You're probably wondering, what's a treatment? So treatments are different values or components of the explanatory variable applied to an experiment. So say you're doing a study on a weight loss drug. The treatment there would be giving them the weight loss drug or not giving them the weight loss drug and seeing the results. Now, sometimes you don't want people to know if they received the treatment or not, so you might give them a placebo instead. A placebo is an inactive treatment that has no real effect on the explanatory variable. When participants do not know if they've received a treatment or a placebo, it's called blinding. So blinding is not telling the participants which treatment a subject is receiving. When doing experimental studies, it's nice to have a control group. A control group is a group in a randomized experiment that receives an inactive treatment but is otherwise managed exactly as the other groups. Let's take some time and go through some examples that should look a lot like your homework. Our first example. In a study, the data you collect is temperature in Celsius. What is the level of measurement? So as we're thinking about this, we want to ask ourselves, what level of measurement? Well, temperature is definitely going to be a number, right? So that means it cannot be nominal and it cannot be ordinal, because nominal and ordinal are going to be qualitative data. So that means temperature in Celsius is either interval or ratio. The correct answer would be that it's interval. Remember, temperature is one of the types of data that I said will always be interval. There is no true starting point for temperature, and we cannot create meaningful ratios when we're talking about temperature. So temperature will always be interval. Our next example says, in a study you collect data. The data you collect is color of shirts. What is the level of measurement? So as we're thinking about this, color of shirts, that's qualitative. So we know that it has to be either nominal or ordinal, and it cannot be interval or ratio, because nominal and ordinal are our qualitative types of data. Then we ask ourselves, is there a way that we can order this? There's no way of ordering the colors of shirts, so we would say this data is nominal. In a study, the data you collect is ranking of artwork as poor, good, excellent, etc. What is the level of measurement? Again, looking at this one, we see that our data is going to be qualitative. But as we think about it, there is an order to our data. It goes poor, then good, then excellent. So that would mean that we have ordinal data. In a study, the data you collect is age in years. What is the level of measurement? As we look at this and think about it, we see that age is going to be a number, which is a quantitative type of data. Then we ask ourselves, is there a starting point? Can we make a meaningful ratio out of ages? There is a starting point for age. Your age starts when you're born. So this is going to be ratio data. In a study, the data you collect is number of traffic tickets. Is the data quantitative or qualitative? Well, we are talking about numbers here, and numbers are quantities, so that means it's quantitative data. Determine whether the value is a parameter or statistic. In a sample of students who passed statistics, 85% use statistics in their future careers. As we think about this one, the difference between parameter and statistics is based on whether it comes from a population or from a sample. Here we're told it's from a sample. It specifically says in a sample of students. Therefore, we know it's a statistic. Is this value from a discrete or continuous data set? The average rainfall in July in inches. We ask ourselves here, can rain be a decimal, or does it have to be a whole number? Rain can absolutely be a decimal number, so that means this would be continuous data. Keep in mind, discrete data values have to be whole numbers. Continuous data values can be decimals. A political scientist surveyed 34 of the current 133 representatives in a state's Congress. What is the size of the sample? The sample size is 34 because we only surveyed 34. Now, what is the size of the population? The population would be 133 because there's a total of 133 representatives. Does this describe an observational study or an experiment? The temperature on randomly selected days throughout the year were measured. Keep in mind, in experiments, you're doing something to impact your data that you're trying to collect. In observational studies, you're simply seeing it and recording it. There's nothing you can do to change what the temperature is on your randomly selected days, so this is just an observational study. In a study, the sample is chosen by surveying every third driver coming through a toll booth. What is the method of sampling? This is systematic sampling. Systematic sampling is when you sample every kth item that you come across, here being drivers coming through the toll booth. This concludes our lesson for Chapter 1.